Hello, kids. I'm going to be sharing with you today a little bit about what I do for a living. I'm Mr. Zeronian. I'm Amy Davidson's father, and she's asked me to talk to you a little bit today about engineering and engineers. What is an engineer? So there's one type of engineer who drives the train, but that's not the type of engineer I am. There are other engineers that are problem solvers. We fix things. We fix equipment. We make things, we come up with solutions to problems that you deal with every day, okay? So what's a problem that you deal with every day? The battery on your phone is dead, right? So an engineer had to come up with a way that you can charge that phone so that you could use it again and again, or design that battery so that you don't have to carry a big, huge battery. You need a little tiny one to fit in your phone. And so these are the types of problems that we do every day. What are some problems that face the world? We have food and water that we need to eat and drink, clean water especially, healthcare, medicine, transportation, our cars, airplanes, trains, boats, and then keeping our environment clean. All of these things are problems that were solved by engineers or are being solved by engineers. Okay, what does an engineer do on a daily basis? We think creatively. So engineering is a way to, how do I solve this problem? I have a problem, my machine doesn't work. I have another problem, I want to fix this so this new refrigerator fits into a smaller space but still holds the same amount of food. I want to go to Mars. I want to drive a car on Mars. Okay, so engineers think creatively and then turn around and solve those problems. They come up with ways to solve problems so we can do these tremendous things, okay? And these things, what do? They change the world, okay? There's all different kinds of engineers. There's what I am, a mechanical engineer. I deal with machines and metal and equipment, motors, and all kinds of things like that. And there are electrical engineers, there are structural engineers who build bridges and roads and buildings. There are chemical engineers that work with oil and gas and plastics and all kinds of things like that. There are biotechnology engineers that work with medicines or prosthetic devices or design the X-ray machine or the CAT scan and other kinds of equipment that are used in medicine to make people well. There are software engineers, people that write the games you play or make the operating system that works inside of your phone, and on and on and on. So anybody who's solving problems can be categorized as an engineer, okay? Here's some things that we've done again too. Super glue. Think about super glue. Do you use that on a regular basis when you crack a nail? Satellites that bring your TV or that send your phone signal all around the world. Your laptop computer or your cell phone, it was all something done by engineers. Clothing that repels mosquitoes or waterproof clothing, Gore-Tex. Okay, these are things that were made by engineers. Engineering problem solving works through a design process. And what that is they have a step-by-step method by which they go about solving problems. And then we do it again, and we do it again, and we do it again until we come to the solution. And then even then, we do it again to make the solution better and make it better and make it better again, okay? We actually come to solutions by failing, by making mistakes. So the first thing we have to do is identify the problem. What is the problem? I need a way to roll my plants to the backyard so I don't have to carry them because they're too heavy, okay? And so I think about, how could I do that? I brainstorm all different kinds of ideas. Well, I could tie it on a piece of wood and have my horse carried in the backyard. Or I could put it in the trunk of the car and just drive around the other way and then take them out. Or let's see, I could make something with a wheel and push it. Yeah, maybe that would work. So we come up with ideas in this brainstorming process. And then what we do is we design what we think might be used to solve the problem. And we figure out, okay, it needs to be this big and this wide and this high and carry this much weight. And then we build that. And then guess what? Then we get to have fun. We get to try it out. Oops, it broke. Okay, well, what happened? Well, the wheels aren't strong enough. Okay, well, we either have to put less on it or we have to use bigger wheels. And so we redesign it, and then we build it again, and then we test it, and then we redesign it, and then we build it, and then test it, and redesign it, and build it. And eventually we get to a point where, hey, we have this thing called a wheelbarrow, and look, you hold it with your hands here and you push it, and it works. So I can carry my plants into the backyard. And then we share that solution with other people that we think might benefit from it. Hey guys, I got this neat thing. It's called a wheelbarrow. Look what I can do. And not only can you do that, but you can put your kids in it and take them for a ride. So it does double duty. Okay. That engineering design process is the problem-solving method that is used throughout just about all engineering problems, okay? We're constantly on the lookout for problems. What do? Okay, so we have a challenge. I want you to think right now, I want you to think about a challenge that you might be having in school or in your home or in your car or whatever it may be. Think about a challenge. And then I want you to discuss with yourself or with another friend, hey, here's a challenge. How can we solve that? Okay. Have that brainstorm. Think about different ideas, all kinds of ideas, and they could be crazy ideas, as many ideas as you have about how to fix that problem. Okay. I want to make a boat that runs on solar power. Okay, well, how can we do that? And how far do we want to go? And so on and so on and so on. And then what you get to do is build it. You design it, you figure out what you're going to need to make it, and then you build it. And then you test it. Oops, the boat sank. Well, that's not going to work. So let's evaluate that design again. So think about how you could do that with your friends and then discuss what happened. Okay, hey guys, I tried this and it didn't work. Yeah, but I tried that and it did work. And you share your activities together, and that whole design process gets reinforced, and you're able to solve those kinds of problems. And I have something here for you I want to show you. This is a video of what happened when engineers sometimes make mistakes. Now, fortunately, nobody was hurt when this bridge fell down that you're going to see, but this is a real bridge in the state of Washington that was designed by engineers, and it did not last. Here's the video. Now, what happened there was that the engineers were unable to consider the effect of the wind blowing on that bridge. The place where that bridge was built is called Tacoma, Washington. It's in the Tacoma Narrows, and there's a canyon that the wind blows through, and it caused the bridge to twist and roll back and forth and back and forth until eventually it fell down. Now, fortunately, nobody was hurt in that. So they had to rebuild the bridge, and they learned from that failure about what they needed to do to design the bridge so that it wouldn't collapse, even if it did move around. We have the same kinds of things today with big buildings that are designed to move because of the wind or because of earthquakes or because of other kinds of events and not fall down. Okay, so sometimes the design process, and remember, because you build, then you test, then you redesign, and then you build again. Sometimes that process takes a much larger effort to finish. Sometimes it happens on the actual thing that is being built, okay? And sometimes it fails dramatically, like that bridge, and other times it's not a big deal. If you think about the airplane, maybe a lot of you have flown on airplanes before. They've only been flying airplanes for a little over 100 years, if you think about that. And they went from nothing, the Wright brothers made a glider, and then they made a plane that they could sit in. And the first flights that they had were only about the length of a football field. And 100 years later, we fly every single day. Well, guess what? There were some accidents and some failures and a lot of things that had to be learned that unfortunately created problems, and we had to build and test and redesign and build and test and redesign, and these things are still even taking place today. So learning to be an engineer is learning how to fail and deal with those failures and understand that the first time you do something, it may not be perfect, but that's okay. As long as you keep at it and you learn and you learn and you learn and you work harder at it and you figure out what it takes to do the job. This is a big part of engineering. Okay, so I'm going to tell you a little bit about what I do on a daily basis as an engineer. And I work for a company called the Gill Corporation. We make materials that are used on commercial airplanes and military airplanes. It's in the interior and the exterior of the plane, but it's a honeycomb material that is used to strengthen panels like plywood, if any of you know what that is. And it gives the airplane strength, yet allows it to be very light. So we make this material, and I'm responsible for the machines that make that material. And so on a regular day, I have work that maybe for, if there's a machine that has broken, we have to figure out how to fix it. We also want to try and figure out how to keep that problem from happening again. Other things that I do are if we need a new machine, we want to make something different that we haven't made before. We want to make something larger than we haven't made before, or other kinds of variations. And so we have to figure out what is it going to take to get a new machine that allows us to do the new process that we work on. That's one part of my job. Another part of my job is working with the environmental requirements for the company. So we have a responsibility to report about chemicals and other kinds of things that we use in our company. We have to keep track of that, and every year we prepare a report. It gives people information about what our company is doing. Another part of my job is about utilities, all the gas and electricity and compressed air and steam. We use all these kinds of things to make our machines run. And so making sure that we have enough utilities is important, plus also looking for ways to be more efficient. Hey, what if we changed the lighting to LED lighting? What if we made this motor a little bit smaller because we know that we can be more efficient? Or what if we turned this off when we're not using it, or slowed it down, or other opportunities? Plus, other engineers are making new machines all the time, and they're getting better and better and better. And at some point in time, we say, you know what, we've had that machine a long, long time. It's time to put it away, and we're going to get a new one because the new ones are more efficient, are better, are more accurate, are faster, are stronger, whatever it may be. And so there's an evaluation process going on where we're looking at what things are available now. It's just like buying a new car. Hey, I got an old car gets 20 miles a gallon. Well, if it's 20 years old, the new cars get 50 miles a gallon. Is that better? Well, it may be better if it's big enough and everything else and does the job. So we make a decision based on that. Should we buy a new car? Yes. Okay. Another part of my job is health and safety. So it's my responsibility to make sure that the machines are safe to use for the workers that are using them every day. Okay, we want to make sure they're things that aren't sharp, or they can't get burned, or they're not hot, or that electrically they're safe. They're strong enough so that it's not going to break unexpectedly when we're asking them to do things with it. And so there's a constant process of evaluating the machines. And unfortunately, people get hurt from time to time. Sometimes it's not very serious at all, but still, we don't want anybody to get hurt. So we look at the equipment and say, hey, how can we make that better? How can we make that safer? How can we make that easier for the operator to use? Another part of my job is putting together instructions and teaching people how to use the equipment. Okay, here's your new machine. And then I have a responsibility about how do we put together the instruction book? How do we tell this person, press this button, turn this knob, flip this switch over here, and then punch this on the computer, and then this is what you're going to do every time to make the part that you need to make. Okay, so this is an important process too. I know how to use the machine because I made it, but now I have to teach somebody else how to use the machine, and that's a very important thing to do too. All right. All those different kinds of things are things that I do on a daily basis. All right. Over and over and over again. Okay. The last part of this, I want to talk about what type of schooling did I do to become an engineer. So I went to high school, regular public high school like you. And then I went to a university that has a mechanical engineering program. They had several other engineering programs too, but they had an engineering program specific for the type of engineer that I wanted to become. And the classes that I took, there was lots of math, physics, chemistry, no biology, which is maybe as good, but if I was going to be a biomedical engineer, I would have taken some biology classes or other classes related to medicine. And then we have some very specific engineering types of classes that teach us how do we calculate if this is going to be strong enough? How do we calculate if this is going to be fast enough? How do we calculate if this is going to make sure it doesn't wear out when we're using it, to make sure it doesn't break when we're using it? All these different kinds of things, learning about different types of materials, all different types of metals, all different types of plastics, learning how electricity works and electronics. Hey, if I want to put a motor in something, how do I do that? And then other specialized classes that relate to a very specific type of manufacturing methods. How do we cast something? How do we machine something? How do we mold something? How do we form it? And, oh, okay, I want to make this. I know I need a piece of steel. It has to be this strong. We can use this method to form the steel in the shape that we want. And then we're going to put a motor and all these different kinds of things. And that usually takes about 4 or 5 years to go through a typical engineering program. The neat thing about it is, again, you have engineering goes from here all the way over here, like I talked about in the beginning. Okay. Remember, what do engineers do? Engineers solve problems. Could you be a doctor and an engineer? Yes. Could you be an engineer and be an engineer? Obviously. Can you be a teacher and an engineer? Yes. Could you be an accountant and an engineer? Could you be a chemist and an engineer? Yes, and yes, and yes, and yes. So whenever you're solving problems in a creative way and using that process that I explained, that design process where we identify the problem and we think about how we could solve it, and then we go try it out. That is the process of engineering. So I hope all of you will think about that, the questions that I posed you earlier. Think about some problems you face every day. No, not your baby brother or sister. Okay, we're not going to engineer those problems away. But I'm sure you all have challenges that you can come up with creative ideas to solve. And I encourage you to try engineering out. Thank you all and take care. Bye.